Let me take another example B. Let me change the color so that is easy to visible. So d by dx f of x, if we know that the differentiation concept in terms of the limits. Yes, if the function which we have that is equal to square root of x, we can write it as this function x power 1 by 2. Yes, so and we know that the concept of differentiation differentiate this, so we will get the value of the limits which we can hold with the help of this function. Let me take the limits. Let me first explain the differentiation definition in terms of limits. So limit h tends to 0 f of x plus h minus fx divided by h. So if we try to solve this function, like if we try to solve this function, so we can write it as limit h tends to 0, limit h tends to 0 square root of x plus h minus square root of x divided by h. So if we put h tends to 0, so denominator what we have 0. And if we talk about numerator, so if we put h is equal to 0 here, then there is a square root of x, and here is a minus square root of x, that would be cancelled, and finally we have the 0 by 0 form. This is falls in under the indeterminate form, which we have seen in the previous lectures. So this falls in the indeterminate form. If we use concept of conjugate here, so what we can see after multiplying with the conjugate of numerator, so we will see like this square root and this square root is going to be cancel out, because if we multiply to square root, that would be removed. So x plus h, we have plus x here, and here what we have minus x here. What we can understand, if we multiply, then this term plus x and minus x would be cancel out, and after that the h is remaining, and that h is going to cancel with the denominator. Let's see how it goes. So limit h tends to 0 square root of x plus h and minus square root of x divided by h, and if we multiply the conjugate of that function, so x plus h minus x inside the square root, and in denominator we have same term x plus h plus square root of x, here also plus. Yes, this is the conjugate of the numerator. So if we multiply, what we will get here, you can remember again the concept of a square minus b square is equal to, in the first round bracket we have a plus b, and in second round bracket we have a minus b. Yes, so let me change the color so that it would be easy to visible. Okay, so finally what we have, limit h tends to 0 x plus h minus x. In the numerator we have x plus h minus x, and denominator we have h. In the round bracket we have x plus h plus square root of x. So what we can see here, if we see the numerator, if we see the numerator, there is a term plus x and minus x, so this will be cancelled out, and h is remaining, and in denominator we have h, so h and h would be cancel out. So what we have remaining, limit h tends to 0, finally we have this term. Yes, so if we put h tends to 0 here in the this is square root, so h is going to 0, and there is only root x, and one root x is here and one root x is here, one root x. So we have 1 upon 2 root x.